So I'm very happy to be here and to talk to you. I have to say I'm a little bit nervous because it is the first time to speak here in Bangkok for such a big audience. And I was asked to give a speech about daylight design strategies, and I managed to do it in a way that I was thinking what could be somehow inspiring for developing the daylight design. And therefore, because I'm a teacher, I thought it could be good to have some basis information, and then trying to take this basis information, these very easy things you, I think, might know already, but to transfer them maybe in a direction where you could develop new thoughts. So it is not showing solutions, it is maybe more asking questions and giving some aspects of maybe new thinking. So this is to introduce me. So I'm a lighting designer, I'm an architect, and I'm working at the Hochschule Wismar. And then I have also a partnership with a colleague where we have an institute for buildings, energy and light. And we do architecture and lighting design. And it is a little bit experimental. And I will show you one of these buildings, not the newest one, but maybe the one where where I can show some things in the end. In the beginning, I will start with a short introduction. What is our university? What is our university teaching? So we have now the chance here to be so far away and to do a little bit advertisement for us. And then I will talk about the question, what is lighting design? And because design strategies, daylight design strategies, what is lighting design, where do we use it? Introduce a little bit the idea of dynamic lighting, and then I will switch to the daylight and trying to give you some insights about the daylight, something sometimes very basic, sometimes maybe leading a little bit more far. Yeah, this was the lovely town of Wismar. It is World Heritage, it is a small town, and the former students who have studied there, they tell me that they would like to go there back sometimes for holiday, because they remember it as a nice time to having this lighting design program, architectural lighting design, founded 2001. It is named architectural lighting design because we want to make it a little bit separate from maybe other lighting design educations which are connected with theater or other fields. We want to educate people who are lighting up architecture, indoor and outdoor. So we are also working for the public spaces and for the private and for the indoor spaces. It is a 4-semester international master, 120 credit points, language is English, 25 international students per year, and the background of the students should be architecture, design. Some are engineers if they have an idea and affinity of for designing. Then we have a new program since 2012. This named is, or the title is lighting design, but the undertitle is architecture lighting design again, and we added design management. This is actually an idea we got in the cooperation with this university, with the KMUTT University, that it might be good to have also a deeper view on the design management, to understand how to run an office, how to develop the business, and also how to manage a project. yeah, this idea was created here in Bangkok, and so it was clear that we are doing this together. And so this is a cooperation, this program is a cooperation with KMUTT University and Hochschule Wismar. This is taught also in English, now also with 120 credit points, and because it's part-time, it takes 5 semesters to get them. 25 students again, it's so our loved group, and the background is the same, and the degree is also a Master of Arts, which is accredited in Germany. And this is a new brochure you can get maybe in some weeks, and the picture shows the student work, a workshop we did with the on-campus students. And if you want to apply, you can do it till the 30th of August. But I think most of you are already lighting designers and don't have to apply. Okay, the lighting design process. What is lighting design? It is difficult to find a definition for lighting design. So I was thinking how to do that, and then I typed very quickly some aspects about that. Lighting design is a creative process and which aims to achieve a functional, atmospheric and emotional touching lighting in a given physical surrounding. Architecture lighting design. According to the situation defined by the task, the expected behavior and the social position of the user, and respecting the requirements of human physiology and psychology and the environment. So I think this shows the complexity of lighting design. It's not a simple thing somehow you can add in the architectural design process in a small slot between the planning and the realization. It is something which should go through the whole planning process. The lighting design is something which covers, as architecture, all the scales of the design process. To make it a little bit more clear, meant with the scales also, let's start with a very small scale where you have the social position. So what does it mean, social position of a user, of someone who is using the situation which is made by the light? For example, here you have 2 or 3 persons standing around this table and chatting and having a leisure situation. And this leisure situation is the social situation, wherefore they want to have a certain light which is emotional and which is giving a good environment for that. So it wouldn't be as nice to have a drink together if it would be floodlighted like a football stadium. So I think this is a special lighting for this social situation. Then expected behavior, human psychology is an atmospheric lighting. And if you see this wheel there, then you will see that you should enjoy yourself. It is something where you should have fun, and it is not only the wheel, it is also the light, and it advertises that this is now a season where you are, where you have a joyful preparation for Christmas. So it's Christmas lighting all in Graz in Austria. And then we have, the last part, the, let's say, functional lighting, the task lighting, which is normally the lighting where we are forced to give answers as a lighting designer. People start with the task lighting. What light do I need for reading, for writing, for running an office? And that there are very often the requirements of human psychology, the ones, physiological requirements, excuse me, the physiological requirements, so the visual system which we are using, the ones which are responsible for the solution. So these are functional solutions. So I try to make up the scope of lighting design, and you will find also this scope if you're thinking about daylight. But first, this is not a daylight picture, it is artificial light. First I want to show you a project from our office. It is Seebrücke in Heiligendamm, which is the Baltic Sea, and it is a prominent situation. And the idea here is to have a lighting which is good visible, to see, aha, this is the Seebrücke, and you can see it also if it is a blue hour from far away. And if it is getting darker, also the light is a little bit dimmed down, because now it is less light needed to make it visible. And there is also a part where this pier is lit not by the poles. There it is side lit for having a good view over the sea. So this should change, the light should change during the night, could go down, and if it is really night, there is only a little bit light remaining so that people can see that it is working. And if they are coming, then it starts again to be a little bit brighter to a certain level, which depends on the hour. This is another lighting we did also at the Baltic Sea. It is a monastery. This is a part where we had to do the public lighting, and we were also thinking that it could be good to have the idea or the feeling that the luminaire, the light from the luminaire is reflecting and lighting up the facade. So it is only a low lighting for the facade, but we decided then to make this with an extra lighting so that we can reduce the lighting during the night and have so a lighting which is appropriate to the functions and appropriate to the social situations. If the facade is lit, people want to meet, people want to stay there. If the facade is not lit, they want to leave. Similar thing here in Stralsund, also at the Baltic Sea. It is a harbor situation. People want to see from far away the buildings, but they want also have a bright lighting in front of the houses. This was a fight with the community, with the responsible persons, because they said we want to have only the facades lit, not the area in front. But in the end we could convince them, and it was a huge step in the further on development for this region to have some light there on the floor. And it was not only a lighting for the distance, but also for the distance, the reflected light is lighting up the first floor so that it is from the distance, the whole facades are lit. And the last project to show you the design process and to show you also dynamic ideas is this. It is a power plant in Schwerin. And this power plant should be lit in a way that people are more proud about this industry part, because the owner is the town, the city, and they were not so happy that the people were saying we have an ugly thing there. They wanted to show this is important for your life, and this is also something where you benefit from. So they decided to have a better lighting than before, and because this power plant is not visible from everywhere, we were choosing only this, let's say, postcard views where it is possible to see the power plant, and these parts of the buildings are illuminated. The story is to tell, had to tell is that this is an energy storage, and this energy storage has different levels to be filled. If it is empty, it will be nearly non-lit, especially in the upper parts. And if it is full, like now, then it is brightly lit so that you can see that there is energy stored for the people, which is produced in these white houses. So it is a clean energy which is produced there with the green chimneys where no dirt is coming out. This is a story which is behind that. It is not really the truth, but no dirt, but it is as less dirt as possible for such a power plant than these. And we had then to illuminate also the biogas production to make it again a little bit more clean. And biogas is something which is green and it is transferred to the gas which could be used. So we were using several colors. And I think it is good readable, and also the reaction we got from the public was that they enjoy it and they also agree to this storytelling system. Okay, so lighting design is what I already said and described, and the lighting design process is going in 3 main steps, especially if it is a dynamic process. So first you have to develop the concept, then you have to develop the hierarchies, which is what is important, what is less important, what could be lit for a longer or a shorter time, and then we have also to understand what is the reason for that, so we have to develop the algorithm. We are doing these thoughts, and that's why Professor Archer asked me to start with this. We are doing these thoughts in European research project called Dynamic Light, where we are trying to find out how the lighting design process could be structured, that lighting designers could develop dynamic, this means changing situations, also for the public. For the interior, we know it in a way like we have done it here by switching off the light in front and leaving it in the end. But in the exterior, in the public space, you can't do it. You can't go out and switch off and then you're coming and switch on your street lighting. This is, I think, something which is only in very few situations possible. So we are trying to develop a process for lighting designers to develop this, and also for the cities, for the responsible persons to develop a way how they could find the possibility to describe which requirements the lighting designers will have to fulfill. And therefore, we were talking about a long list of analysis what should be done for every lighting design concept. And for making this analysis, you need data. And for this data, we developed a monitoring tool. These are the main questions which you have to ask if you are trying to develop for public lighting a dynamic concept. And working on this, it makes me thinking that it could be also good to develop a process for lighting design in general, because lighting design is something which is different to architecture design. Because, as I said to the students some minutes before, if you are designing architecture, then you are designing something which is there. So you are designing a construction where you have to think that it is not falling down, and then this construction can wait till the users are coming. If you are designing light is something which has to be consumed immediately, because light which is not perceived, which is not seen, is not existing. It is gone, it is wasted. So if you are lighting up an empty room, the light is there, it costs energy, but it is not seen, so it is not reality, because light has to be consumed immediately. So it is better to have a room which is not used, not lit, than having their light which is not used, which is also not waiting for a user, which is only there randomly. For that you have really to look very closely what are the people doing and what do they expect from this scenery. So, for example, some people do not want to walk alone during the night because as it is too dark, so we have to develop a solution that we can see the road where the people are walking so that they are not falling, and therefore we need, for example, then the solution light in both sides of the street or an illuminated sidewalk, so that we can have this very clear way from monitoring the situation, understanding what the people there, the stakeholders are doing, and then trying to find out the requirements and in the end finding the light solution. So this is where we are now, and we are going on developing this in our research project so that it is more simple, more handleable later on. Now it is a little bit complex and complicated, and we try to make it more simple, more understandable, so that a lighting designer and also the authorities have the possibility to have a platform to talk and to understand themselves. Because we have the feeling that this is not existing and needed for complex design tasks like dynamic lighting is. Yeah, and if you have different lighting moods you want to create, you have also to think about the reasons to change them, the algorithm. Now let's come to the daylight. Having this in mind, this long starting period in mind about the design process, what does it mean also for the daylight? The daylight is fantastic. The daylight is something which is changing, which is everywhere in another situation. 80% of our perception is visual. 90% of our time we stay in a room, inside a room. What does it mean? If we are designing the lighting for a room, the daylight is a very important thing, because if the daylight design is a very important thing because mainly we are inside, and if we want to use the daylight, and we will come to the reasons why to use the daylight, then it should be better to do or then it is needed to do this also for the interiors. So a good interior design does not mean only artificial design. Good lighting design for the interiors means automatically also a good daylight design. If we leave it to the architects, very often the solution is driven by the form of the facade, but it is not respecting the differentiated, the changing daylight. It is not respecting also the physics the daylight has. And so I will go a little bit through these things which might be for you not new, but maybe it is inspiring to get it so together. Daylight is changing everywhere, every minute, every second, and it is so different. You have direct sun, you have diffuse sky, and you can do with the daylight, with the daylight you can make the architecture alive. With the daylight, a good daylight design, you make the architecture alive. The design of space is the design of light, means the design of daylight mainly. And if you look at these pictures, you have already seen it is every time the same picture. But thinking where the light is coming from gives you every time another illusion how the room is meant, what is floor, what is ceiling, what is it an artificial light direction, or is it a direction which is coming from the natural daylight. So also for designing the daylight, we have to understand the design process, and we have a similar design process as I mentioned already. Here we have in the beginning also the monitoring, the degree of daylight utilization. So what is given from the architecture, what can we do? And then we have also the demand analysis. We have to look what daylight is needed and how could we combine this, what is given and what is needed. And there is the pre-design for the daylight. Then we have also look more in detail what is the building orientation, the form of the building, the daylight availability, and then we are putting all this together with developing a strategy, deciding about windows and glazing, shading and visual comfort, and then we optimize the thing and we're going back then to the daylight systems if they are needed and integrating all this into the building service or in the building itself. So it is a long way, this daylight design, and as you can see normally, it is somewhere here that you have given windows, not selected windows. You may give a comment to the glazing, and then you have problems, and then you can decide about the shading systems maybe, and how this, about the shading system here, and how this could be integrated then in a maybe developed artificial light concept. So I think it is needed to start in the real beginning if you're talking about daylight, during the whole process of architecture development, and we should think what will be the end. The end will be a comfortable atmosphere with low energy costs. So let's think about in some chapters about daylight. One could be learning from the nature and understanding the physics of daylight. I think this is for everyone common what it is and what it means. This is a curve which is showing what the sun is doing. This is depending on the latitude of the city or the situation where you want to talk about, and then you can see here the month lines and the hour lines, and then you can find the sun position exact, talking about the azimuth and the altitude. And I think this is an easy thing, and if you know that daylighting and sun position is something so easy, then it is also easy to respect it if you are planning a building, as you are also respecting the width of the area where you are doing the building. This very simple form, this very simple connection brings so many different results that it is possible to, if you have an open eye for the beauty of the daylight, to find everywhere, every time, new signs of this beautiful thing. So for example, here in Denmark it's a little bit, it's also Baltic Sea, you can find these very long shadows in summer. It's not, or in early summer, so it is not a winter picture. Or if you're looking at that, if you can see here the blue shadows you can get and the reddish color of the sunlight. Or even the diffuse sky can have a beauty with this different kinds of blue and gray, and it's a very nice play together with the nature. And to get this information, which is given by the natural light into a building. I think this is a task, because daylight gives us unconsciously the security about our physical surroundings. Daylight is telling us what the weather are, where the season is, where the location is, what's the time of the day. So if you have a room and there is a small window which brings this daylight information into the window, or if you have a high-rise building and there is a staircase where the light could come in from somewhere, not enough for lighting up, but if you are respecting the light so that it is visible, it gives so much information, it gives so many interesting aspects for the people using this building that, yeah, it's incredible. There is a research, for example, that schools, pupils, when they have the chance to see the daylight and when they have the chance to look outside, they are much more successful than pupils who don't have the chance. In the 17th of the last century, we were building schools without daylight connection. It's, from our viewpoint today, it's incredible that we were not respecting these possibilities we have. But daylight is not a simple thing. Daylight causes also problems. We all know that daylight, if it comes to the Earth, is filtered, and only a part of the daylight is coming to the Earth, and all this is bringing energy to the Earth, and this is absorbed, this is reflected, and if it is absorbed inside the building, then it is heating up the building. I think it is a very common thing here in Bangkok that you know that if you have a big window and there is a lot of sunlight or also daylight coming in, it is heating up because it's energy when it is absorbed. So you can see it here. This is the energy. It is not luxes or something lighting designers are talking about. This is the energy in watt per square meter, which is in the daylight, and it is here shown according to the frequencies, according to the spectral things. And you can see the visible part, which is shown here colorfully. This visible part is as big or bigger than the part which is not visible. So if we are talking about we let the visible light in and the infrared light is not coming through the glass or is reduced coming through the glass, then we will have again an energy problem. So if we have a glass which is not taking the visible part and not taking the infrared part, reducing everything, it might be the best, but why is the window as big? So these are questions where we will a little bit think about further on. But the beauty of daylight, how is this working? Why is the sky blue? So it is a very easy thing. Also, the daylight is not visible, like the artificial light also is not visible. But in the sky there are a lot of very small particles, and these very small particles are scattering the daylight. And because they are so small, they are scattering only the blue wavelengths, and that's why the sky is blue. And when there is a cloud, then their particles are bigger, and they are scattering a bigger part of the spectrum, and then the sky or the clouds are white. So it is a very easy thing, but it is also interesting to know because this is producing the information what we are reading to understand our surroundings. And if the sun is going down, you can have interesting things, and this is a good picture. Here you see the blue sky, then you have this dark cloud, and then which is white or dark gray, and then you have here the red sky, and you can see here it is raining already. Here is the atmosphere very wet, and this is why it is red, because if the sun is very down, it's very low, the way of the light through the atmosphere is more far, and also the particles close, is more far, and so also the red light is, the wrong way. And so the red light is coming through, and the blue light and maybe also the rest of the spectrum is absorbed. And this makes a difference to what I said before. If the sky is blue, then the sky is blue because some of the blue parts are scattered and the rest is going through, so we have also the full spectrum with a little bit less blue, but blue, as we have seen before, is a lot in the natural light. So we have all the white lights, the full spectrum coming down. But in the evening, there is the blue light and the green light is absorbed by the atmosphere. So this sunlight is really red. And we saw it in the reflection on the sand we have seen before. So, and we can learn this here, the yellowish part, the orange part, there the blue parts of the light are already absorbed. And this you can see here with the blue light first and then with the red sunset in the picture above. Yeah, this was the wrong direction, that's why I was talking about the same slide again. So this red light is really red light, and so everything looks much more reddish than by day. A similar filtering effect we have in the greenery. If we have a wood like this and we have all these nice patterns on the floor, we have a filtering effect, green filtering. And you can see it here in the face. It's my daughter and my grandchild, by the way. It's very small, the grandchild. You can see in the face that it looks green. It is because my camera was not doing a white regulation. I switched this off to have these effects also visible. And so you have this greenish face, which is caused by the green light, which is produced by the trees. So this very nice atmosphere you have under the greenery is also part of this selection process, of this physical process you get. And here it is the same, that the greenery is selecting the things, but it is also the greenery is selecting the light, but there are also the possibilities of reflections. So if you can see it here, you can find the daylight coming in. Obviously the daylight mainly is coming from above and is reflected by the floor. So which is, if we are thinking about lighting design, a very simple thing, but very often forgotten. You make a daylight design, you make a bright ceiling and a black floor, and you're wondering why no daylight is coming into the room or it is not distributed in the room. Here it is a very good thing. It is a white floor and you have a very good daylight part. If you are aware of these things, you find sometimes these wonderful things you can find produced by daylight. So this is a reflection from this orange roof through the window to the stair. And you're coming down the stair and you're wondering, what is this nice orange light and where it's coming from? It's not a sunset as we have seen it, it is reflected daylight, and the reflected daylight is also an orange light because the rest of the light is absorbed. Daylight has another changing quality, it is the intensity. So here you can see the overcast sky in different months, and you can see the overcast sky is, let's say, half of what we can find with the clear sky. So this is somehow also obvious that the energy, or here it is Eluxis, that the illuminance which is coming from the clear sky is much higher than the illuminance which is coming from the overcast sky. But what does it mean for us that we have this differentiated light distribution? It does mean that if we want to have a daylight in a room which is somehow stable like the artificial light is, then we have to find a system which can control the daylight in a way that it is taking away more daylight if the daylight is very bright because it is direct sun, or because it is another month, or it is the noontime. And so there are a lot of different lux levels coming into the room which are producing a lot of different lux levels, and we want to have stable, then we have to do some changes with the shading systems or the window systems. This chapter now is about physiology and psychology, and this is a very short one because I don't want to talk in front of lighting designers about the seeing process and something like that. I will only mention two things again because they are important. One is that the luminances and illuminances we can find outside are incredible high. I have to tell you because you can't read it. This here on the floor is about 20,000 to 100,000 lux. 100,000 lux you can find on a floor if you compare it with an indoor situation where you can find 1,000 lux and it is very, very bright. Then you can see that it is not only a physical thing which makes us feeling this is a bright situation and this is a less bright situation, it is also something in our brain which is working there. And so what we think is bright and what we think is less bright, this has something to do with where it is. Is it a light inside? Is it the direct sun where we shouldn't look at? Is it a cloud which has here 8,000 candela per square meter? Or is it here somewhere the blur which is, I can't count, 1,000 million candela of square meters? We are really able to see in such a width of brightness that it is incredible if we are talking about the interiors that we want to fix on 500 lux, for example. But we have another feeling of that if it is interior. And we would have also another feeling whether it is not the sky which is so bright, but the snow which is so bright. It is not the same. It is our perception process, but it is also our brain which is doing a lot for making us possible to see these high different things. Then the other point is that we learned how daylight is right, and so if we all know that the daylight in the evening is orange, and so we don't see the orange. We see it maybe in the first moment if we are coming out and see, oh yes, orange, after a while it is gone. This we call constancy of perception, and this is something which is important if we are trying to work with the beauty of daylight and to develop it. But it is also important that we have to respect the natural things, the way how the nature is treating the daylight, and that's why I'm talking so much about that. What we remember from a situation is also very much inspired by the by our by what we see, by the, let's say, the postcard view. so that something what we have seen as important and nice, we will see it also and remember it also as important and nice. And then you all know there is also another process which is mainly inspired by the daylight or driven by the daylight. This is our internal clock, and we know that the internal clock is run by these blue wavelengths. And you see that then by the sun the body is regulated, and this is also done by daylight. And if we have no daylight, our biological clock is not working. So we need, science say, half an hour a day, daylight, bright daylight, then it might work in a healthy way. But daylight has also a cultural background, and daylight is also talking about the way how we perceive the situation and how we act. So daylight is also leading our way to how we are acting to other people. And for the daylight, the main principle is the principle of control and self-control. I don't want to go further on in this aspect. It will be another lecture, but if you are interested, this is something we can talk about later. Then learning from the indoor climate and the human comfort, we have first the visual comfort I want to show, and I don't want to talk so much about this because visual comfort in a room is described for the artificial light. For the daylight, it is mainly that we say it should be glare-free, which means that the luminance differences are not so high. So it is the thing is that we should have a daylight distribution in a room which is more even, and there are not hot spots like direct sun coming, shining on the board, and you can see anything, nothing anymore. I will come a little bit to another point. This is a thermal comfort, because also the thermal comfort is depending on the daylight, and we see that we want to have a temperature 36.7 degrees, and we have a lot of possibilities to make it possible that this temperature is the real one we want to have. It is not only that we have air condition in a room, it is also that we have a lot of self-regulating systems in our body. But the sensation of heat, and this is important for the daylighting, is depending not only on the air temperature but also on the surface temperature. And if we have a cold surface, then we feel that the whole situation, also the air temperature, is lower. If we have a warm surface, then we feel that it is warmer. In our country, we like to have a warm surface because we want to feel warmer. But if you, and how does it happen? The sun is shining directly on the sun is shining directly on a wall and warming up the wall, or shining directly on the floor and is warming up the floor. Here in this country, it might be much better to have the sun or the daylight to lead it into the room in a way that direct sunlight is not warming up a surface, and that the glass is not warming up because it is single glass with bronze color, which is warming up a lot because it's absorbing a lot of heat. No, you should think about possibilities to keep the surfaces cool, as we are thinking about having in winter times surfaces which are warm, so we like it if the sun is coming deeply into the room. So temperatures are really differentiated. Not everyone needs the same temperature. It is a very personal thing. So it makes also no sense to have a temperature fixed. It is something where you have to have a dialogue with the people who are using the room. Short cut. Now we were talking about the humans. Now we are talking about the building. The building is, or how daylight is coming into the building is defined by the daylight factor. I think you all know it. The daylight factor is something where you can compare different buildings, different rooms, according how much light is coming into this room. So it's a percentage from the outdoor and the indoor lighting. So this can be calculated, and there are a lot of factors which are influencing that. For us, interesting should be only the glazing, because the glazing, if you are first on the windows and the light which is coming in, then you can see again what I have already talked about, that there is a lot of energy, and here you can also see what I have already shown, that the diffuse sky has less energy and the direct sunlight is very powerful. Then let's come to the glazing. The glazing has different abilities, and what is interesting is, I think you all know that there is energy and light is going through, is reduced, and so on and so on. If you have a single glazing, then you would have here a warming up of this glass, because this is absorbing the light. It's not only reflecting, it is also absorbing the light, and the rest is going through. If you have a double glazing, then you have this system twice, and this reduced energy, this reduced light is again a little bit absorbed, and it is warming up the glass. If you have now a selective glass, then it happens that it depends on the quality of the glass. It happens that the visual glass can go, the visual energy can go through, and the not visible infrared energy can stay outside if it is a good glass. But it is not only reflected, it is also absorbed. And so it can happen if you're using reflective glass, especially only one glazing, which you can see more often here in Thailand, that you get a heater in your room because you get a hot glass. And the hot glass is working like a heater. And it is heated up by the absorbed energy. So it is not, the heat is not staying outside if you have a glass which is more absorbing the energy than reflecting it. Yeah, and here you can see it. This is seen from this building outside, and you can see it is one glass in this room, and you can see outside it is a clear thing. This is another building, and here you have the tinted, the green effect, because there is a filter to let the heat outside. Yeah, another thing which is important for thing which is important for the quality of daylighting is how deep the daylighting is coming into a room, and therefore it is important where the window is. And a very simple rule: you can get as higher the window is, as better the daylight distribution is in the room. But if the window is very high, you have a problem that you can't look out and see the beauty of the city. So what it will be the best, I think, is a combination, having a smaller part to look out and a wider part for getting light into the room. Why I'm talking about the width and the dimension of the window, I made this picture and measurements in my hotel room now, preparing this lecture. And I found that if there was only a little bit the window open, it is less than 10 centimeters, I have already in 2 meters distance 50 lux. And this 10 centimeters, it's diffuse sky outside, it's not very bright. These 10 centimeters are enough to lit up the room in a way that I was happy with that. So only a little bit energy is coming also into the room. If I have it nearly 80 centimeters was it, then it is 300 lux in 2 meters distance. And this is enough for having a working area. So you can work in this room by having this small slit of light. And this low energy is coming in. If I'm opening the window nearly half, it is already 1000 lux. 1000. And if it is really open, it is 2000 lux. And now it's a hotel room. The whole day the window is open like that, because the service is open it, and the heat is coming in. But would it help if they close it? No. They have chosen a brown curtain. And if the brown curtain is brown from both sides, is closed, 80% of the energy is absorbed by the curtain or the glass. So I have a heater. So the difference is, there is a difference, yes, but the difference is not so big that maybe it will be the same closing it or open it 2/3. So what would we need in this room for reducing the energy costs for cooling and making it more comfortable, not to have all these air conditioned the whole day and evening? We should have a curtain which is adjustable to the needed light, maybe automatically. And this curtain should have a high reflectance so that the energy, the light, could be reflected outside. Best outside the window, but if it is not possible in another way, it could be also inside the window. Then the glass is getting hot, and what we talked about already. So this is important because the sunlight is the most has the highest efficacy for lighting up a room. The efficacy says how much watt do you need to get what lumen. And if you have the direct sun, for example, but let's say here's a diffuse sky, because this is where we were talking about, it is 125 lumen per watt. You need a very good LED lighting on to come to this level. So every artificial light brings more heat into the room than the daylight. But unfortunately, our windows are not able to be adapted to the need of the daylight. That's why we have the problem that we mostly have too much daylight. So we close the curtain, still the heat is coming in, we put the air condition on, we switch the light on, and we have everything together. Air condition and the energy consumption, light, energy consumption, and bringing heat into the room, and the curtain, in this case the brown one, which is also heating up the room by absorbing the sunlight. So what we are doing to defend us against the sunlight has sometimes not a real physical background. That's why I'm talking about that. So this is, at one hand it is basic knowledge, but at the other hand is something where our daily experience is telling us something else. So, yeah. Then, let's talk a little bit about different regions. Yeah, I have a little bit time left. Let's talk a little bit about different regions. This is a map where you can see the solar radiation over the world, and you can see it is not everywhere the same. There are hotter regions where the sun has more power, more energy, and there are regions where the sun had less energy. Here is the Baltic Sea. It is not so much. We are happy in summer, and in winter it is cold. And where we are here, it is also not the hottest area, but it is really hot. So also the sun path is different, which makes it more difficult to deal with the sunlight in the northern part, because the sun position is changing a lot from the north to the south, northwest, northeast to the south, and it is also the sun height is also changing a lot. So we have times of the year where the sun is very, very low, and we have times of the year where the sun is higher. And we have it here. I think it's all well-known things how this works. If we are now talking about high-rise buildings, this is one in Bangkok as an example, then we have first to think that the difference is that in Bangkok, a very good thing is that every evening it is nearly the same time when it's getting dark, and every morning it's nearly the same time if it is getting bright. And here in Wismar we have a big difference. So in summer it is the whole night more or less bright, and if it is in winter there's only a short period. This has something to do with the time where the daylight could be sufficient. In our region it is 80% of the annual working time we can work by daylight. 20% we have to have artificial light. Here in Bangkok it might be easier. Okay, you have rush hours, you want to meet the rush hours, but if you are going with all in the morning to the work and coming back in the evening, you have more or less the whole time the chance to use the daylight. And this means, if this is research which is recently done from a researcher team in the Netherlands, it is a calculation, it's not a measurement. They were calculating the same buildings in 3 different positions. In Amsterdam, because it's Netherlands, in Sydney and in Singapore. And you can see the lighting, interior lighting in Singapore, it is only 5%, because they know exactly when it is dark and when it is fine in the morning. Here it is, in Sydney, it is a little bit more, 9%, and in Amsterdam, which is in the north, with these high differences in the day, it is 11%. And you can also see here is a little bit heating needed, but also a lot of cooling, because there is a lot of internal warmth. In Sydney and in Singapore you have no heating, but you have cooling, and in Singapore it's the most. So nothing astonishing. If it comes to the building type, then you can see that normally you say that this building has the lowest outer walls, or the lowest facade, so that the facade is the smallest, so the possibility that warm or cold air could, warmth or cold, and energy could leave the building or energy could come into the building, is very small. So this is a round building, that's why here it is marked as the one which seems to have an ideal form, but they calculated in Amsterdam it would be better to have this oval building, because this oval building could be better put in a direction that the sun could be used. And then you can see the different buildings, and you see the worst building is that one, which is in Europe very often used for high-rise buildings, this form, because it allows a smart stair system. And then you have the same for Sydney. You see the first small differences, but it is more or less the same. You see, okay, this is here in the other direction because it's on the southern hemisphere. Here's Singapore again in that direction. And here you can see first changes, but you see that the energy consumption depends a lot on the form of the building. Then they did a research, then they were calculating how this is changing if you are changing the position of the building to the sun. And this is showing how this is changing. And you can see this is the tropical region. This is here. The direction doesn't matter really. And in the temperate and subtropical region, it is quite different if you have these long buildings, whether they are orientated to south-north or orientated to east-west. These big facades. And this is bringing this together a little bit to the window-wall ratio. This means how big the windows are. And this is now for daylighting the interesting question. If you have a temperate climate, it is between 20 and 30%, and the form of the building is not such a big difference. This is a very compact building, and this is one of the long ones. In the subtropical buildings also there is a difference, but the expected one would be that the windows could be bigger here in the compact building, and that's true, and also the same in the tropical region. But what is interesting, we have 20 to 30% in the temperate region, and we have around 20 to 40% here in the tropical region. But we never have, it is not recommended, what we can very often see, 80 to 90% wall-window ratio. So what we are doing really is to build two big windows. We don't need so much daylight, we don't need so much energy in a room. And here you can see it then according to the different directions. And the deep plan, this is the squared building you see in the temperate. There is not such a big difference, but east and west is not so recommended. It is double using the energy. In the subtropical, if you have the windows to the north, it's a problem. Because the sun is coming into really, and in the tropical there's also a difference. So if it is orientated to the south, it is the best, and if it is orientated to east-west, it is not so good. And for the narrow plan building, you have really big differences what the direction is, north or south, in every region. In the subtropical, a little bit less than in the tropical. What does this mean? This means that in a temperate region, to east and west, no or very low glazing are useful. Most should be, average could be to the south, and a big window, no, and it depends, it doesn't matter really what it will be to the north. And coming to the tropical, which is here, again, no glazing to the east and west, and to the south, 10 to 55, and to the north, 10 to 35%. So it is a real low part of the facade which should be glazed to have a recommended wall-window ratio to have a low energy consumption. And this is somehow worldwide a right summary of what I said. The cooling strategy is minimizing artificial lighting, because this is bringing heat into a building, preventing that heat or can come in or can go out, having a shading which stops the direct sun, because the direct sun has more than double energy than the diffuse light. And yeah, having maybe also some natural cooling ideas and some ventilation. Because for getting, because if the direct sun is coming into a room, is heating up a surface, or also the diffuse sky is heating up the surface, this surface has to be cooled down during the night. This is what we try in Europe, and so that it can catch energy again on afterwards. But here it is not so appropriate because the temperature differences are not so big. So you can get out this overheating only by mechanical things or by wind or by other things which could cool, like, yeah, okay. So very important is that we get an appropriate number of energy into the room, and therefore you can find a lot of systems. These systems are now, which are now used, are mainly in a way that they are changing the architecture a lot. Architects are taking them now as a design tool, but I think it would be also interesting to think about where to direct the building, how big the windows should be, where should be the window in the facade, and is there a simple system to work with that. So this is for the European country, the ideal house where everything is thought about, how to get light and sunlight in the winter times deep into the building, how to have a shading during the summer times. And yeah, this type of building is used sometimes, not very often, but sometimes, and these are ideal things for the European area where you want to have it open, but it could also work here because it has shading possibilities to the south, and the south, where the sun is also here in the highest position, is a possibility to have a very easy shading by an overhang. Yeah, this is then the winter idea, to get energy in, to warm up the houses, and then how to distribute this heat in the house is also interesting, to have a ventilation system. Yeah, this is how you can use the sun energy as I described it, and it is important that this wall is hotter than the air, so that the wall can give heat to the air. If it is at the same level, then it is not working. So it means it has to be heated up during the day to, let's say, 28 degrees, and then it can give the energy into the room during the night. We can also change the building very much by having shading ideas, by integrating it into the building, by having something which we are hanging in front. Here you see it's really the architecture influencing, because it's the west side and they wanted to have light and they wanted to have shadow even if the sun is deep. I think this is making a new building. Or you can use more smaller devices like light direction things which could work prismatic, like it is shown here. Or it could be a prismatic louver from other producers, this is shown here, which is directing the light up to the ceiling with the idea that then it is coming back to the room and can lit up the room a little bit further in the depths. And there are a lot of systems. We were developing now 10 years ago this with holographic, with a holographic system in our university, together with University of Dortmund, the University of Dortmund. Unfortunately, we found out it is not able to bring it on the market. It's too expensive, and also the material is not available anymore. Here you can see if you are doing something into the window to direct the light to the ceiling, and it is reducing also the amount of light in the room. This you can't do some redirecting of light to make the room brighter. You can only make you can only bring a little bit light more in the back part of the room. And then these shelves could look also very sophisticated. They could be glass, they could be formed in metal. You could have a shading device which is interior or in between the glasses, so that you have it more clean from outside, and you can have a shading device which is not stable enough against the wind. You can use systems like this who can react without changing the system, react to different sun positions by having different parts for the reflection. And you can take sun protection glass, but I have talked a lot about this sun protection glass. It has really it has to be selected really very well, and it is a solution which is, for my opinion, not the first. It is the last possibility if you have no other possibilities. And then you have here the possibility of double glazing, of shading in between this. You can have also these interactive systems where everyone can open or close the window as they like it. It could be also structuring the facade in an interesting way, so you can also program it that the form of the building is changing according to the sun level. I'm not so sure whether this is a solution which should be done everywhere. And to summarize these systems, I'm not showing systems like we can find them now in Dubai or very sophisticated things, because I think it is every time first the question, do we need a system? Wherefore do we need a system? And isn't it better to make the architecture before we are using help systems in a way that the light is respected? And therefore I will have a short look through the history and then show you two examples, and then I'm ready. So in the medieval times the windows were small, and in the times around the 18th, the change to the early 20th century, the buildings were still organized in a way that you had a corridor, and this corridor was daylit, and you had all the offices daylit. This is a typical office building, and even the central hall was made with this fantastic tower in a way that it is daylit. There is no, there you can see a little bit decorative artificial light, but there is no real artificial light needed. But because of the technical evolution, because of the technical possibilities, architects were thinking more and more, we don't need these daylit parts, and I think this is the wrong direction. So in the Bauhaus, still they were very daylight orientated. They opened the building, okay, it's to discuss whether it is producing a good climate. I would say no, but they opened the building and they have everywhere the possibility to have daylight. Even this corridor is somehow daylit. And then famous architects, but not only they were deciding it is also enough to have a dark corridor. Here is no window at the side. The corridor is totally dark. It's totally artificial lit. And this was from 1957. There was a trust in electrical energy and also into the electrical sources, light sources. So what does this mean? This is again the daylight factor, you know that, and this means that depending on the ratio, but only a little bit, in the depths of 6 meters of a room, there is not enough daylight. You can do what you want, there is not enough daylight. So it means that if you want to have a building which is daylit, you have to have, after 6 meters, another room which has to have a window on that side. And if you want to have a corridor in between, then you have to think about a trick to get daylight into this corridor. So the depth of a daylit building is limited to 12 or 15 meters. And this is what we can find normally very often in office architecture. If it is not high-rise because of the lift and staircase system, there the dimensions are a little bit another one, but very often with parts without daylight. I have talked about this already. This is our architecture building, and this is our, it should be an example for modern and good architecture. And what did the architects do? 100% glazing facade to the south. So it is more than 3 times than recommended what we have seen in this recently research I was quoting. So they had to do something, they had to bring this in front, and it is 50 centimeters wide and 50 centimeters high, and it has a possibility to look out. It's not so bad. Here you can see how in March the sun is going around, and you see that it is not really the south position, so the sun is coming deeply between these shelves. But even if it would be the sun position, then you can see here the degree of 45, the number of 45 degrees is excluded, because if the sun is higher, it is reflected from this system. Only if it is lower, it is coming into the room. But what you can see here also very easily is that between 9 o'clock in the morning, in the whole time between August and April, and also here in the afternoon, the shading is not working. Only in the high summer season, in these 2 months, the shading is working during the working hours. This means normally our building is too hot. This means we open the window. This means because it is also heating period, the heating is switched on, the window is open, and we have a high energy consumption in this building. Unwillingly, because the architects has not thought this problem to the end. What do the users need? What is the sun providing? And how to deal with that? They haven't done this analysis which I was talking about in the beginning. And that's why I was talking about this lighting design process so much in the beginning. And here it is again. We have to do the full process from the beginning to the end, then we can do a good lighting design. Yeah, to teach this, we have a light lab, and in this light lab the students are doing experiments, finding the influences of the daylight factor, finding the influences of the direct sun coming into the room for glare, causing the problem of glare and overheating, and then they have results like this where they can understand the needs of architecture better. This is a very interesting building in Vorarlberg. It is from Baumschläger und Eberle, and this building is not heated, even if it is in Austria, in the mountains, where it is cold in the winter. And they are doing this by having an appropriate number of windows in all directions, so that they can get the diffuse skylight from everywhere and can get the energy if they need it. And if it is too much during the summer times, there is an automatical system which is opening the windows so that the fresh air, that's a benefit of our region, that the fresh air can go through and can cool down the building. And in winter times it is so well insulated, and enough sun is coming in, and the interior heat of the people and the machines is enough that the building is warm enough. In between, and this is the name of the building, the temperature 22, the coldest, and 26, the warmth. The trick is, it is an open building, and the ventilation can go through everywhere, so if here is heat produced, the heat could be used in this corner also. Next example I want to show is a museum, traditional forms of museum lighting. I want to mention this museum. This is a small museum in Ahrenshoop. Ahrenshoop has an art tradition, and they wanted to have their own museum which looks like small buildings, and they wanted to have in the top, or there is a possibility to bring in light in the top, and the rest is closed. So what happens inside? You have this big roof. This big roof is white painted. The light is coming in this small area, only in this small area into the room, and because it is reflected all over the room, you can get a very diffuse light. And as you can see here, you can also get the information from the daylight, which is so important for a museum, that it gets also the daylight information into the building. And here you have more pictures of that, how it looks like, and this is a system. On the roof there is lying a prismatic system which allows that no direct sun is coming into the building, and the diffuse light which is coming in then is re-reflected several times so that you have a perfect museum lighting. And here the lighting designer, it was Andreas Schulz von Lichtkunstlicht, was working together with the architects from the beginning. If they found the form, they were doing this together, and they were discussing a lot about alternative openings and then finding this very simple solution in the end. Now the last I wanted to show, it is an atrium, and it is a kindergarten, Kindertagesstätte Plappersnoot. This is a building what we designed, and it is a very European solution because I think it won't work here in this region. The idea was there were a lot of buildings, about 300 looking like that, 2 buildings, and in the midst these all were corridors. So a lot of heat loss here in these corridors. They were only glazed, and it was really difficult to heat up this building. Very easy solution for that. We thought, okay, we want to cover all to make the walls smaller. Here we have a new interior. We don't need insulation here. We have insulation only to the outside walls. And we can repair the heat legs with a system, with a hole we can add here, which also gives more playground for the children. And you can see that this factor here, which is showing how many walls you have to the outside, is decreasing. The system is that this is the hall, this is how it looks like, and the system is that in summer the air is going through from the building through the outside to cool down the building, and in summer during the day there are more openings so that the heat is not coming into the building anymore, and in winter the heat from the hall is going into the rooms, and in the night it is heated up by radiators. So a very easy system. And for the roof we were selecting this ETFE foil, which has the possibility to have different shading possibilities, so that if the sun is very strong, it could close itself and it could open, so that the sun can go through more if it is a diffuse day, or less sun in winter times where you need it. So the effect is that the temperature in this hall is every time around 7 degrees higher than outside, only in summer if it is open in a way that it has the outside temperature. So it's then open in the roof and in the lower parts, so that there is the outside temperature. It's a well working system, and the children are enjoying this very, very nice new atmosphere. So it is using the daylight for heating up, but it has also the quality that it is a day-lit playground, which is important for the people, for the pupils, for the children. And the EFTE foil has the capacity to let the UV light through, and also the UV light through, so that also some benefits of the daylight are can the children get, and flowers are growing and so on. Yeah, some more pictures, happy children. And then I want to show the next building, only 2-3 slides. Here we had the same building, but we were choosing another solution. We were covering the midst of this hall and having the light only at these sides, because we thought this might be enough, that the use here is easier possible. We have shaded areas. We have not such a glare problem, because here the children should play, but there is also a sports ground, and there is also the possibility at this closed roof to use it for PV, for electrical production. And this is the interior. You can see the bright walls, which for my opinion is the most important thing for have a lovely indoor feeling, that you have bright walls which can reflect the daylight deeply into the room. There is one big difference, that's why we were choosing this. This hall is heated, and therefore we needed a better insulation for the roof. Thank you for your patience.